Okay, example 3 here, we're going to graph a vertical shift. Now, we skipped over the lesson where they went into detail about tangent graphs, so I'll tell you just a brief thing about them now. With the tangent graph, the main difference, or there are a few differences really, but the main difference, I would say, is that the tangent graph repeats itself every 180 degrees, kind of your standard tangent graph. So if we thought about the unit circle here, our tangent is going to be our opposite over adjacent. Um, if you keep an eye out for not the blue line, not the green line over here, but the gray line, okay, it heads up towards an asymptote, reappears on the bottom, heads up again towards an asymptote, reappears on the bottom, heads up again. Okay, and when we see that over here, that kind of lets us know that our repeated behavior, our cycles, are happening twice as often. You don't have to make it to 360 degrees to cycle through the tangent function. You actually have to make it to 180, and then you're back to where you started. Okay, right? So up, flips down to here, up and back to where we started. Up, flips down, and back up to where we started. So that is why on here they are telling us that the period in this case is going to be not 360 divided by b, but 180 divided by b. Okay, so they have two different ways that this graph has been changed. We have a b value that's going to affect our period. So that is going to do a horizontal stretch or compression. Since it's a fraction less than 1, it's not going to compress it, it's going to actually stretch it out. And that's why we're seeing here, we're seeing a period that looks like it's going 360 degrees, right? If I shifted it back towards where we're going through the origin, I think these 90 and, what's the next one here? 450? 90 and 450 would be 360 degrees apart, right? So we have that 360 degree period because we have been horizontally stretched by a factor of 2. We've stretched with this b value of 1/2. Okay, so if we've got that figured out, the next part is the -1. Well, that -1 should be our well, no, it's not horizontal because there's no parentheses here. So if this had been parentheses x minus 1, it would have been a horizontal shift. Since it's just out here on the end without any parentheses involved, this is our k value. So this is why our midline, midline's a little harder to conceive of on tangent than sine and cosine, right? Because on sine, it was the line that like the function oscillated above and below. Tangent functions, they don't necessarily oscillate up and down in the same way, but it's the same concept. It's the middle of the tangent function. It's where this like little inflection point is right here as the graph kind of starts to accelerate upwards at that point. So we have moved that midline down by 1 unit by doing this -1. Okay, so we see two different things in there. Let's see them play out on here. So if I did my 1/2 in front, that will do that horizontal stretching by a factor of 2. Whereas if I had a 2 here, it would have actually compressed it, right? We would have taken our tangent, and this 180 will hop down to 90 if I do a 2. But if we're doing 1/2, 0.5 right here, that's going to horizontally stretch it out. And then we are going to lower the whole thing down. We're going to bring this from 0 down to 1 way down here by doing this vertical translation. And I believe that is what they want, right? They just want the, well, let's go through the amplitude, the period, the phase shift, the vertical shift, midline. So the amplitude, it's a good question. What do we say about the amplitude here? I'm gonna have to look that up. Amplitude of a tangent. Should still be the, yeah, that's kind of what I was thinking. It should not have an amplitude. It doesn't have a maximum or minimum. So this line is not going up to some value and coming back down. It's going up to infinity, and then as it approaches its asymptote, it flips down to negative infinity and then rises up. So there's really no amplitude to speak of. There's no highest point and lowest point. The highest point is infinity, the lowest point is negative infinity. Guess you could say those were the amplitudes, but that's not really how people usually talk about it. The period here is that 360 degrees that we got by doing 180 divided by the b value. The phase shift would be none at all. I don't think we've changed anything about the phase because we don't have anything in parentheses next to the x. We do have a vertical shift where we've lowered down by 1. And midline equation. Well, the midline equation for this is just y equals -1, right? Y value is always at -1 along this dotted line. And that would be it for example number 3.